Hi, my name is Vahan Davoudian. I'm a physics experimentalist for 30 years, and today our topic is going to be cathode ray tube and discovery of X-ray. First of all, I'd like to thank so many people. They just emailed me and they love the histories, and today I'm going to have a real good history for the X-ray and the vacuum tubes. And it says, I just so appreciate that, they emailed me. That's a good feedback, and always the history is so important in science. So from now on, every time you see my theories, it comes with a history. So I tell you who did what, and then gradually, step by step. And in fact, today it's going to be so comprehensive. You're going to love this. And because I got everything from the, exactly beginning, who did that. For instance, nobody, no physics book mentioned that Michael Faraday also started this, vacuum tubes, and we have no idea. But that book was so old, I found it in Barnes and Noble. But anyway, so I will explain everything. And I'm hoping that you guys are going to love this. Like I said, it's so comprehensive, and I just explained everything with a great precision. Okay, so it's called Cathode Ray Tube and Discovery of X-ray by Vahan Davoudian, physics experimentalist, and this is my email, vahandavoudian@aol.com. And in fact, so many people worked on this, but one of the greatest scientists, his name was William Crookes, and he was amazing English scientist, and that is his tube, and you can tell there are so many, different shapes and different types, but William Crookes was so good, and in fact you can see this tube is so different, and you can tell there is a cross like here. The reason why he did this, he just wanted to make sure that those electron beams are just blocked, and he was right. So that is clear indication that when the electrons are from here coming to this end, always if something in a way, so it blocks it. And Mr. William Crookes did this, and of course I have to mention something. These vacuum tubes are so important in our life that it led to the discovery of electrons, which is the most important subatomic particle, and on top of that, X-ray, which saved humans' life, that's so important. So I just explained step by step, and in fact, in 19th century, so many people experimented with these tubes, but William Crookes was one of them. And like I said, it was so good, this discovery, and the electron by J.J. Thomson, and after that, I will explain what happened. And this is what I meant by the history in 1838. And no physics book has ever mentioned this before, that Michael Faraday pioneered this. But unfortunately, because I'm a science man, I always make sure that everything is conclusive. You have to finish the all the experiment. But Michael Faraday was great. His insight was maybe 100 years ahead. He was so amazing. In 1838, Michael Faraday had a tube, but I don't know. Unfortunately, I have no the picture of it or anything. I couldn't find it. So he had two electrodes, and then that was a tube. But I have no idea, was it completely vacuum? Because at that time, Michael Faraday didn't have a vacuum pump. What he did, he just extracted, he could as much as he could, but it was not 100%. And then he realized when those two electrodes are connected to a high voltage, so what happened, he can see the glow inside the tube, and then that was amazing. That was the beginning of this tubes that finally it ended to cathode ray tube, which is so important, and it is used in technology. It used to be used in color TVs, color monitors, but they don't use them anymore, but they use it in so many things. So that's why Michael Faraday did. But I have to explain about a professor of physics at the Cambridge University. His name was J.J. Thomson, and in 1897 he discovered electrons. So I have to clarify something. Mr. Crookes or William Crookes set the stage for J.J. Thomson, because he knew that those beams of electrons can be deflected with electromagnetic coils or electrostatic plates. And then J.J. Thomson was so smart, he had to figure it out, and then finally he realized that that charge is a negative, so the electron was born. So in other words, that was so important. And imagine how important electron is in our life, in technology, for chemical bonds, chemical reactions, and ionization, everything, electron is involved. Because in other words, electron does the work, not the proton and the neutron. But amazing. So Mr. J.J. Thomson did, and in fact I will show you in the tube he used. So let me take this off. But I have to post this so you can see. This is a block diagram of the cathode ray tube. Well, of course, it doesn't specify everything because it's just a block diagram. But I like this. The reason why it has two plates. So the beam of electrons can be deflected horizontally or vertically by the plates, which has got electrostatic deflection, and also by coils that you can see over here. But this was the old one, and then I just wanted to show you that how it works. So the beams are, the electrons are high speed electrons, high energetic, are, from here come to here, and then this screen is coated with a phosphorus, and what happened, the phosphorus is absorbing the energy, and is like a Nbor theory, and after they drop to the original level, and then what they do, they emit electrons. And you can see this is the color TV, and this was like, I would say, 40 years ago almost. And you can see we have 3 electron beams, and then 3 cathode ray tubes. The reason why, because this is colored, but the black and white had only one. Then you can see there, coming from here, the electron gone, and then here is a phosphorus, and then every time they hit the thing, and then they emit light or photons. And this is the one I was talking, Niels Bohr, and this is so important. In fact, I brought this up so many times, and I'm sure you guys remember this. See? So the electrons are, hitting the phosphorus, tube, and then after the energy is absorbed and they emit, electrons or photons. That is exactly what it is. So you can see absorption, and here's the emission. But I have to show you exactly what I mean by those. And in fact, I had to remove this. This is from color TV. I hope you guys can see it, and you can see the coil, and the cathode ray tube goes inside that hole. You can see right there. Well, of course, I had to remove that because it was huge. And you can see these are the deflection coils. So in other words, this is electromagnetic deflection. And of course, I have to mention something. And this is a high voltage. Well, of course, I had to remove the whole thing. This is the small version of the Nikola Tesla coil, which is, step up transformer, and the voltage is amazing. Sometimes it goes to 20,000, 30,000 volt, but the current is so low. And always that vacuum tube has to be a little bit not 100% vacuum. So what happened, I will explain now. So this is the tube. You can see these are the coils, Mr. J.J. Thomson used, and that was, I think he made this because he was great, experimentalist, at the same time great physicist at, in England. And then you can see that this is the cathode, and then these are the coils, and one is for the, deflections of, horizontal and vertical. So he did it, but he was so genius, he figured out the, ratio of mass to charge. And one amazing thing is, you can see here there's a calibration. So he could measure exactly the deflection, because you won't be able to, get the weight for the, electron. The only way you can tell the deflection, how much is the deflection, and then you can figure out the, not the weight, exactly how it works. So Mr. Thomson did this, but you know what, this started with in 1855. His name was Heinrich Geissler, and then what he did, he was the good scientist, at the same time he was a good instrument maker. So what he did, he was so genius, he came up with a vacuum pump. Unlike the Michael Faraday, that, like I said, his experiment was not conclusive because he did not finish. But Mr. Geissler was so good, he came up with this vacuum tube, and then he just vacuumed everything. But like I said a few minutes ago, it shouldn't be 100%. We need a little bit air, but he did it. Then he found out there's a glow. And then another person, also German physicist, came. His name was Clocker, and he did it a little bit further. Then he realized that always one side of that cathode ray tube is illuminated. So in other words, it's not both sides. So it was the one away from the cathode ray tube. So sometimes they call it electron guns. So that's what Mr. Clocker did. And in 1876, German physicist, his name was Eugen Goldstein, he just coined the term cathode ray tube. And then but overall, finally, after so many years, the one who 100% completed this in 1897, his name was Carl Friedrich Brown, and then he completed this. So let me take this off. Okay, and now we're talking about the discovery of X-ray, which was total, surprise. And he was great scientist. His name was Wilhelm Röntgen. He was German physicist, and it was completely surprised because he had no idea that he was going to discover the most important thing in the history of the science. So what he did, he was experimenting with these tubes, and that time, when Mr. Wilhelm Röntgen was doing, that was almost completed, I would say 100%, and he was experimenting, and then he realized to do something special. So it's called unblockable light. So he had a huge thick cardboard, he put it in front of that cathode ray tube, and then he realized that something amazing is happening. In nearby, that was a fluorescent tube, and then he realized that, whenever this cathode ray tube is functioning, so that tube is illuminated. He had no idea where those lights were coming from, but that is why from there the X-ray was discovered, and then this did not block everything. And then he realized that, he had to check to see what is the penetration of the X-rays. So like the humans, bones stopping everything, but the soft tissues, like, everything else, they can go through, and then we get a shade like, white, gray, or sometimes a little bit black, and then we can tell it exactly. But overall, he was doing that. And then he realized that, the papers and things like that, they're not blocking. And the most important thing is, the metals are doing that. Sometimes you go to dentist and you realize that huge vest you're having on, that is so heavy, that is lead. So because the reason why they don't want you to get a lot of exposure when they x-ray your teeth, so they just don't want you to get a lot of exposure to X-ray. So that's what he did, and then he realized that that is cathode ray tube, and that is so important. And from then on, he started doing more experiment. I will explain it now. Well, the reason why this was called X-ray, because it's the after something it is mathematical term, and then that's why he called it X-ray. X means we have no idea what it is, X-ray. So that's why he called them X-ray, and then. Like I said, it depends on how you use it. But the photographic paper, always you can see they get the X-ray. But like I said, and then he also had to invent a camera. But unfortunately, I couldn't find the picture of the camera because he his wife hand. I will show you in a minute. He took a picture, and then that was so good. That was great excitement for them. So then he realized that the X-ray is working, and then so unfortunately, what happened at that time, they were so excited. They were using X-ray with everything almost, and then they realized there's a danger involved, and then they should not, people or humans are not supposed to be exposed to that much radiation, and then they tried to use a smaller dosages. This is another poster. It's showing the X-ray machines and everything else. Let me just put this up, you can tell. This is the picture I was talking about a few minutes ago. That is, the ring, and then that's his, wife's hand. And this is his picture, Mr. Wilhelm Röntgen. And this is another picture of they call it CRT also, cathode ray tube, because this, just changed the world. In 1980, I used to work in a Univac corporation. At that time, we used to use big monitors and TVs and everything else, but now the technology changed, and the TVs, they don't use that anymore, but X-ray machines and everything else, CAT scan, CT scan, everything else, they're using, because cathode ray tube is not supposed to be used only for the TVs, because it's electron gone. So And then this is another one. You can see you have two plates here. One is the horizontal, one is the vertical. And most of the time in my life I have seen not these, but I have seen the coils, which you can deflect the electrons, and then on the screen you can see A, B, C, D, or whatever you want. And then this is the whole tube, and then this is the cathode ray tube, and these are the connections for the high voltages. And this is so versatile. I mean, how indispensable is in our life that the X-ray, how it changed our life. And these are the medical X-rays that penetrating power of the X-ray is good for human body, for tissues and everything else. And then what it is, I mean, medical diagnosis for the technical things, always, it's so important. It's called computerized tomography or CT scan. And I remember I used to talk one physicist. He is working in a hospital sometime, he's just consulting some doctors, and then they are doing radiation. And that's amazing how that works. CT scan shows almost 99, or I would say 100% of everything. But I mean, it's just amazing how it changed our life. And then X-ray is used in astronomy also, because we have some telescope. They can even, detect from, beyond our, solar system. I would say maybe 20, 30, 40, 50 light years away from us, and then they using X-rays, and then we can also check the black holes and everything else, and it's amazing how good it is. So this is the picture of the, I mean, it's not a block diagram, it doesn't explain everything, but this is, like a cathode ray tube here, and then you can see the electrons here, they're emitting, and then you can see, and then normally the way it is, they can just, concentrate on one part of the body. You don't have to do the whole thing. But the MRI, as you know, is doing the whole body, and then it's kind of rotating. But CT scan is always the same thing. But this is just a single X-ray, probably of this part or the chest maybe. And you can see here the shade, sometimes it doesn't show here, unfortunately. Sometimes it's gray, sometimes it's black, sometimes it's a little bit off-white. So you can see this is used in everything. Imagine you are in airport, and then this is your suitcase. See, it shows that you have like here you have like a water, and then you have like a here toothpaste. You have everything. You have a medication here. It shows everything. I have to mention something because most of the time I'm interested in science, and then I speak with most doctors, and especially those guys who are helping doctors, and then for the CT scan and things like that, because I know CT scan is not the ordinary X-ray. CT scan is so good, it's so comprehensive, it shows everything. And then I remember once we discussed the PET scan. I had never heard about the PET scan. Positron emission. That is so good. That is the latest technology, and unfortunately I couldn't find any picture of it or any explanation for that. But overall, I will tell you in a simple language what it is. PET scan, whoever has a cancer, so they can inject special things in their vein. And then what happened, that is like a glucose. So it goes in your body, and then what happened, because your cells have to consume the glucose, in order to survive. And then if they consume the glucose, and they will find out that the cancer cells are active. If they don't, and then they realize that that a PET scan is working, which is called positron emission. Well, of course, I'm hoping that I can research more and then find more about that. And then I'm glad that you guys, I'm hoping you guys love this video, even though it was short, but I almost covered everything. And like I said, why Mr. Louis Pasteur said something amazing. It says chance only favored prepared mind. So Mr. Röntgen's mind was prepared. He was great physicist. I mean, how could he know that, he discovered the X-ray? Because his mind was prepared. And like Mr. Louis Pasteur said, chance only, favors prepared mind. So I'm hoping you like this video, and if you like this video, and then you can subscribe it, and if you have any concern or if you have any question, you can email me. I'll be happy to answer, and then I will always, even if I don't know the answer, I will just dig it out for you. I will research it, and thanks a lot for watching. Appreciate it.